Hi guys, this is Equilibrium 102, Part 2B, and what we're talking about is finding equilibrium partial pressures or concentrations if you're given initial data. And so the big picture here is we're going to use an ice table. Kind of like what we did at the end of Part 1. So here's a question. We have a reaction between hydrogen and iodine, making hydroiodic acid. And we have a 1 liter flask at 721 Kelvin filled with 1 mole of H2 and 1 mole of I2. And we want to know what are the partial pressures of H2, partial pressure of I2, and the partial pressure of HI at equilibrium for given Kp equals 50.5. Okay, so the first thing that we need to do, since we're given a Kp, is translate this information into pressures. So we're going to look for the pressure of H2 and the pressure of I2 initially. And since they have the same number of moles, they're going to have the same number of pressure, or they'll have the same value for their pressure. So we're just gonna go ahead and use our handy dandy ideal gas law, PV equals nRT. And so the pressure that we're solving for is both the H2 and the I2. And our volume is 1 liter. Moles is 1. R is 0.0821, and temperature is 721 Kelvin. So this is a pretty easy little baby algebra problem here. We're going to do 1.0821 times 721 basically, and make it partial pressure of the I2 is equal to partial pressure of the H2 is equal to 59.2 atms. So that's what we're going to start with. That's our initial pressure, or initial partial pressures. Okay, so we are going to go ahead and write out our equation again. So we have H2 plus I2 in equilibrium with 2HI. And then down the left-hand side, we're going to write our ICE, which stands for initial change and equilibrium. And then we're just going to fill in what we know. At the beginning of the reaction, there is no HI present. And we can assume that based on the fact that we're given only moles of H2 and moles of I2. And we know that both of these are 59.2 atms to start with. Okay, so what we're going to do in this is we're going to let X equal the change. Okay, so since the system we know is going to achieve equilibrium, our reactants are going to lose pressure, and our products are going to gain pressure. So we're going to say that the H2 loses an amount X, and since they have the same coefficients, I2 would also lose X, and HI in terms of X would be gaining 2X. So the X is the change for the substance with coefficient of 1. And then since this guy has a 2 in front of it, we would gain twice that amount. Okay, so our equilibrium partial pressure expression is going to be 59.2 minus X for H2, and 59.2 minus X for I2, and then we're just going to have 2X for our HI. Okay, so then we're going to use our equilibrium constant expression. Kp is equal to the partial pressure of the HI, and we know that's going to be squared because of that 2, and the partial pressure of the H2 times the partial pressure of the I2. Okay, so what we're going to do is just substitute in and solve for our X. And so we know that the Kp is equal to 50.5, Yeah, I'm going to use a different color here. Yeah, we'll use blue. So we'll say we know 50.5 is equal to the partial pressure of the HI, which we let equal to 2x, and then that's going to be quantity squared, over the partial pressure of the H2, which is 59.2 minus x, and this guy is also 59.2 minus x. So you may notice that this is a perfect square, which is handy. And so we'll get 4x over 59.2 minus x, quantity squared. And then to solve this, we're just going to take the square root of both sides. I'm going to see what's the square root of 50.5. And for this side, we get 7.11 is equal to the square root of this, which is going to be 59.2 minus x, the square root of that, and then the square root of 4x squared is going to be 2x, right? Yeah, square root of 4x squared is 2x. Okay, so we're going to evaluate this, and we're going to get 7.11 times 59.2. Sorry, I was just doubting my own algebra skills there, which is unbelievable. 421 minus 7.11x is equal to 2x. Okay. So again, a little bit of baby algebra. We're going to add 7.11x to both sides. This goes away. We get 421 equals 9.11x. Divide by 9.11. And we get here, x is equal to 46.2. And we want to remember that this is in ATMs. And so what we're going to do is go back up here, take this x, and substitute it into our expression. So we have 59.2 minus 46.2. And so that gives us our equilibrium partial pressure of 13.0. This guy's also going to be 13.0. And then 2 times x is going to be the partial pressure of the HI. So 2 times 46.2, and that gives us here 92.4 ATM. And this will be also an ATM and ATM. So those can get kind of hairy if you don't have a perfect square. You have to use the quadratic formula. Fortunately for us, the AP, well, the College Board, has decided that the quadratic formula is not a part of the scope of our class. And so you don't see problems like that on the AP exam, so I don't expect you to do them. But if we want to solve a quadratic formula at some point, we can definitely do that. Okay, thank you, and hope you're doing good.